సార్ హలో సార్ మీ మైక్ ఆన్ చేయలేదు సార్.
Oh, sorry, sir. Okay, okay. Sorry, sorry. Right, right. Okay, right. Can I repeat again? Validity of hybrid pi model. The validity of hybrid pi model is valid if the loop frequency than less than the unity gain frequency. The high frequency model parameters, the high frequency parameters of this transistor or BJT in terms of low frequency model. We are going to have valid this hybrid pi model means simply high frequency model parameters of a BJT in terms of low frequency model. So we can, the main advantage with this high frequency model is we can convert or we can obtain the low frequency model from the high frequency model. We can obtain the low frequency model from the high frequency model. So this can be achieved by eliminating the capacitance from the high frequency model circuit. Okay. So how we can get the low frequency model from the high frequency model means simply by eliminating the capacitance from the high frequency model. So that the BJT will respond without any delay, without any significant delay. Of course, the delay is very small as compared with the delay between the input and output signal is very small. Okay, it is in terms of nanoseconds or microseconds in small, but there will be a delay at high frequency. This delay can be eliminated, or this delay can be eliminated by converting this high frequency model into low frequency model, high frequency model into low frequency model. Okay, so in practice or in practical, there will be some delay between the input and output signal of the BJT, which is very small compared with the signal period, of course, and hence we can neglect this time delay also. Okay, now you can see we can validate this high frequency model of a BJT at low frequency by redrawing this circuit. Okay, this is actually this is a hybrid pi model. So what you have seen earlier, this is a hybrid pi model or simply high frequency model. So this is the terminals of the transistor, base, collector, and emitter. So because we have considered the C configuration while drawing the high frequency model, in C configuration or emitter is the common for both input and output. So that's why we have taken the emitter as a ground, and it is common. The emitter is the input and it is the output. So emitter is common for both input and this is the C configuration hybrid pi model. Okay, we have seen earlier. So there is a base terminal and there is a base junction and this is the collector terminal and this is the emitter terminal. So there is a base spreading resistance and then collect, input conductance and the trans conductance and this is the feedback conductance. This is the output conductance which you have calculated earlier. So this is the output conductance and this is the feedback conductance and this is the input conductance and this is the base spreading resistance. Okay. Now this is the input voltage and this is the output voltage. This is the output current. Output current is IC. Then it is both of this IC is divided into these two categories. This is the current. Now this hybrid frequency model of this BJT is simplified at the low frequency, and we can redraw this circuit. Okay, along with the small signal low frequency hybrid model of the BJT. Okay, so what we have discussed earlier, the low frequency model of the BJT can be obtained from the high frequency model simply by eliminating the capacitance. Okay, this is done by eliminating the capacitance from the high frequency model. Yeah, this is the high frequency model. If we eliminate these capacitances, so this is the one capacitance and this is the another capacitance, we can redraw the circuit. Yeah. So this is the hybrid H parameter model. This is okay. I think you are familiar with the previous previous unit. We have performed this analysis for CE configuration, CD configuration, CC configuration, the approximate model as well as the exact model. So this is nothing but a hybrid model of the CE configuration. In this hybrid model, there is a base current and collector current, this is IB and IC, input resistance HIE and HRE, HOFE and HOE. So this is nothing but hybrid model. Okay. Now we can the high frequency model of this BJT simplified at low frequencies and we can read on the circuit. Okay, along with the small signal low frequency hybrid model of the BJT. Yeah. So if you compare these two, if the high frequency model parameters of the BJT in terms of low frequency model, it is given like this. So so simply the transconductance. Transconductance or mutual conductance. The transconductance and mutual conductance is nothing but it is nothing but the output current by input voltage. Output current by input voltage. This is nothing but the IC by VT. Okay. This is nothing but the output. So previously we have calculated the transconductance GM for hybrid pi model. Yeah. This is nothing but the GM. Okay. So this is nothing but a GM. GM is nothing but IC by VT, where GM is equal to IC means output current and VT is the threshold voltage. Okay. Now the same can be validated for the low frequency model by drawing this transconductance GM is equal to IC by VT. So this IC is the uh, output current or collector current and VT is the threshold voltage. Similarly, the internal base node to emitter resistance or simply this uh, base node to emitter resistance. So B dash is the base node and E is the emitter terminal. The resistance between the B dash and the E, that is nothing but the internal base node to emitter resistance. This is nothing but can obtain by HFE by GM. HFE by GM. Again, the value of GM is equal to IC by VT. Now, if we substitute the value of GM as an IC by VT, so because here the GM is in denominator, so this will become ulta means where is this? So this is HFE into VT by IC, HFE into VT by IC. So this is we can get the value of HFE into VT. This is HFE is a hybrid model. Okay, this HFE is the hybrid H parameter model. Okay, so we can express this hybrid pi model in terms of H parameter model. Similarly, the internal base node to collector resistance RB dash C. RB dash C, this is actually not okay. RB dash C is nothing but HRE into RB dash by 1 minus HFC. This is the formula for which we have obtained earlier. Okay. RB dash. Yeah. RB dash. 1 minute. Just a minute. Will RB dash. RB dash C. Okay. So we can get the value of RB dash C from this equation. Yeah. If you go observe this equation, I will get the RB dash RB dash C. Yeah. This is nothing but RB dash. Yeah. RB dash is nothing but RB dash C by HRE. Okay. RB dash C by HRE. So again, we know the value of RB dash C. So if you remember this equation, okay. You remember this equation and come to this one. Then yeah, we will get the RB dash. This is nothing but the HRE into RB dash by 1 minus HRE. Yeah, we will get like this. Okay. Similarly, by assuming the value of HRE is very less than 1, we can reduce this equation RB dash C is equal to HRE into RB dash HRE into RB dash C. Okay. So the base spreading resistance RBB dash. RBB dash we have already find the base spreading resistance. So here, yeah, this is nothing but the base spreading resistance. This is RBB dash. RBB dash is nothing but HIE minus HIE minus RB dash E. So simply obtain the value from this one. Yeah, now substitute the value of RB dash E. RB dash E we have already find here. Now substitute the value of RB dash E. You will get the value of RB dash in terms of hybrid H parameter model. Okay. Now similarly, collector emitter resistance RC. RC is nothing but 1 by HO. So this is the relation between the these are all left LHS all are parameters of the hybrid pi parameters. These are all. This is the GM is the transconductance and RB dash is the base node to emitter junction emitter resistance, and this is the base to collector resistance, and this is the base spreading resistance, and this is the collector output resistance for collector. So these are all expressed in terms of this parameter model. This HFP, HRE, HRE, and HFE, HIE. These are all hybrid H parameter model. These are all hybrid 5 parameter model. Okay, so these are validated by converting this hybrid 5 model into the H parameter model. So we can validate these. Okay, these parameters. Okay, so again another important thing is the value of these hybrid 5 parameters are valid under the dynamic conditions. These are all depends upon the value of the IC, VC, and temperature. IC, VC, and temperature. So previously, see, if we are having a transconductance GM and base emitter resistance R B dash E, and another one emitter capacitance resistance emitter capacitance and collector capacitance. These are all the hybrid 5 values. So now by using this GM, and we know the value of GM is equal to IC by VT, where IC is the collector current and VT is the threshold voltage. This VT depends on the value of the temperature. This VT is nothing but T by uh, 11 11,600 actually. The VT is nothing but T by 11,600. We know this from the previous the threshold voltage VT is equal to 11 T, capital T by capital T is the temperature, room temperature, and 11,600. So from this equation, we can say that the value of GM is directly proportional to the the value of GM is inversely proportional to the temperature. Inversely proportional to the temperature because of the value of VT is equal to T by 11,600. 11,600. So while you know the value of VT is nothing but 11,600 in the diode current equation. Explaining about the diode current equation, I naught is equal to IC naught. IC naught is equal to I naught by V naught. So I naught is equal to 11,600, where capital T is the temperature, and okay, we can get the value of this one. Now from this, we can say that the transconductance GM is inversely proportional to the transconductance GM is inversely.
సార్ మీ వాయిస్ వినిపించట్లేదు.
ఓకేనా ఇప్పుడు?
ఓకే
హలో, ఓకేనా?
ఓకే సార్.
ఏమో ఓకేనా? ఓకే, రైట్. So next one is base emitter resistance. This base emitter resistance is nothing but the RB dash E. This RB dash is nothing but the HFE into VT by IC. Yeah, this is HFE into VT by IC. If you observe this one, the value of this RB dash is directly proportional to the VT, and then it is inversely proportional to the IC. Okay, if there is a change in the output current, then there is a change in the value of this RB dash E, and there is a change in the temperature. Again, it will changes. Okay, this is the effect of the hybrid parameters. Okay, another one, this where the value of we can validate the hybrid frequency model or the hybrid pi model at high frequency. Okay, so we can validate these transconductance and this RB dash C and RB dash C, RBB. These are all in terms of IC, VT, and VT means temperature. VT is the threshold voltage. Again, this threshold voltage depends on the value of T. VT is nothing but T by 11,600. T by 11,600. This is the standard okay value. Okay, then this IC, VT, and temperature. VC output voltage. This output voltage. So we can validate these. We can convert this hybrid pi parameters into H parameters by using like these formulas, and then we are going to also validate these hybrid pi model parameters under the dynamic conditions with the value by depending upon the value of this IC. IC means output current, VT means threshold voltage, and temperature. Threshold voltage or temperature. Again, this VT depends on the value of temperature, and VCE. VCE means output voltage, or collector to emitter voltage. Collector to emitter voltage. Yeah. Now, next one is collector emitter C short circuit gain. Simply collector emitter short circuit gain or C short circuit gain. Okay. Collector emitter short circuit gain or simply C short circuit gain. So actually, what is the C short circuit gain? Why we are going to calculate the value of this C short circuit gain? So let us consider a hybrid pi equivalent circuit of a C amplifier. So this is the hybrid pi equivalent circuit of a C amplifier. As we know, there is a this is the CE model of the hybrid pi equivalent circuit. There is a resistance at the base rating resistance and input conductance, or simply the input conductance and feedback conductance and output conductance. There are two capacitance, nothing but one is diffusion capacitance and other capacitance is diffusion capacitance and transistor capacitance, or simply trans capacitance. Okay, diffusion capacitance, and other one is another capacitance is trans capacitance. So the two capacitance and four conductances, nothing but the trans conductance, input conductance, output conductance, and feedback conductance. Similarly, so with the help of this conductance, we can get the value of the resistance. Why? Because the resistance is nothing but the reciprocal of this conductance. If it is input resistance and feedback resistance and output resistance. Similarly, input current, output current, and then input voltage and output voltage. Input voltage and output voltage. Okay. So to calculate CE short circuit current gain, let us consider a hybrid pi equivalent circuit of a single stage CE amplifier, which is shown in this figure. So this is a hybrid pi equivalent circuit of a single stage CE amplifier. Single stage CE amplifier. Okay, single stage CE amplifier. We are going to consider a single stage CE amplifier transistor circuit with hybrid pi equivalent. This is the hybrid pi equivalent of the single stage CE equivalent circuit. Okay, if the output is shorted. Okay, if the output is shorted. If the output is shorted means what happened? The value of load resistance is 0. The RL is equal to 0. Okay, when the output is shorted, that is RL is equal to 0. Thus, the value of RL and RCE is disappear. Yeah. So RL and this RCE will disappear. If you short this one, so there is no load resistance or load resistance. The value of okay, when you go into because of the name itself, it is nothing but the collector emitter short circuit gain. If you short circuit this junction, there is no RL, load resistance is zero. Whenever this load resistance is zero, this also disappears. There is no RCE. Okay, no RCE and then no RL. If, remember this one. Okay, when the output is short circuited, but is the value of RL is equal to zero, thus the value of RL is thus the value of RL and RCE is disappeared. RC and RL will be disappeared. The resistance RB dash C, okay, the resistance RB dash C is open circuited since the value of RB dash C is very greater than RB dash E. Okay, okay. So this is the value of RB dash C. It is because it is these resistance will be disappear. Okay, and when we are short circuited the output. Okay, when the short circuited output, then these resistance will be disappear. Okay, then the resistance RB dash C, this resistance RB dash C is open circuited. Why? Because the value of RB dash C is very greater than RB dash E. RB dash this is very greater than RB dash E. This will be open circuit. Open circuited. So to obtain the frequency response of a transistor amplifier, consider the hybrid pipe model. Okay, from this figure. Okay, from this figure, the approximation equivalent circuit can be obtained by using this Miller theorem. By approximation, hybrid pi circuit can be obtained by using the Miller's theorem to calculate the short circuit current gain. To calculate the short circuit current gain. So we can redraw this circuit after considering after eliminating this RL and RC, and it is a open circuited. We can redraw this circuit like this. Yeah, this is the circuit. Okay. Okay. If the output is short circuited, the value of RL is equal to 0. So what will be the flow for resistance of the circuit? So when RL is equal to 0, the value of V0 is equal to 0, and the wave is equal to 0. So the gain of this circuit will be considered here the current gain IL by IC. Okay, AV, there is no AV because of it is a short circuit. So this is the simplified equivalent circuit of this output is shorted. If you shorted the output, you will get the modified this hybrid pi circuit like this. Hybrid pi circuit like this by using this Miller's theorem. By using the Miller's theorem. Okay. By using this Miller's theorem. Yeah, this is the circuit. Actually, this is GB dash E, or simply R. This reciprocal of this one is nothing but the RB dash E. RB dash is nothing but the HFE by GM. Okay, because of we have considered here the GB dash E. GB dash E is nothing but the GM by HF. So 1 by this one is nothing but RB dash E. RB dash is nothing but the HFE by GM. HFE by GM. Remember this one. You can read right here RB dash E. If it is RB dash E, then this is nothing but the HFE by GM. HFE by GM. So here we consider the GM GB dash E. GB dash E is nothing but the GM by HFE. Okay. So there is the capacitance. We know the value of two capacitance CC and CE. CC and CE. Yeah, first one is CE and second one is CC. Okay. Of course, this is the base terminal, this is the emitter terminal, this is the collector terminal, and this is the base junction B dash. Okay, this base junction B dash. Okay. So because of we have started this one, when the value of RL is equal to 0, there is no output. You can't get the output because of there is no load resistance. So V0 is equal to 0. And V0 is equal to 0, the value of voltage gain AV is equal to 0. Why? Because AV is nothing but the ratio of the output voltage by input voltage. If the output voltage is 0, the voltage gain is 0. That's why hence the value of AV is equal to 0. So AV is equal to 0. So the gain that we consider here this for this circuit is that is nothing but the current gain. Current gain is nothing but the output current by input current. Output current by input current. Okay. So the simplified equivalent circuit, this is the output is shorted. Okay. Now also అయిందమ్మా వాసు
సార్ వచ్చింది సార్.
ఓకే రైట్ రైట్ yeah now we are going to find the current gain. A current gain gives the sinusoidal current output current. This is nothing but AC. The output current or load current. Okay, output current or load. We can neglect the value of GB dash C. GB dash C is neglected, and then since the value of the of course I already told you what is the value of GB dash C. This is nothing but the GB dash C. This GB dash C is nothing but it will become open circuit because of it is very greater than this one. Okay. Very as we come with very greater than this one, we can neglect this one, we can read on this one. Okay. Now the value of this GC is disappears. The current delivered to the output is directly through the CE and GB dash C. They are also neglected since there will be these are very small. Now we are going to find the value of IL. Okay. Now from this circuit, what is the value of IL? You observe this one. From this equivalent circuit which we have redrawn from this circuit. Okay, from this circuit we have redrawn by considering some these values. So after short circuiting, so then we will get the value of this IL. Now from this circuit, find the value of IL. The IL is this direction. This is the direction. So both are in opposite direction. This IL is exactly equal to this current, but it is an opposite direction. The value of IL is equal to minus of GM into VB dash minus of GM into VB dash E. VB dash E. Okay. So both are same. What is the current flowing through this output is equal to this one, but the current direction is opposite. The current direction is opposite. This is in this direction. This is in this direction. So we know that the value of IL is equal to minus of GM VB dash E, where this minus sign indicates the opposite sign, opposite direction, flow in the opposite direction. Okay. So now we know the value of IL is equal to G minus of GM into VB dash E. Of course, we know the value of VB dash E. What is the value of VB dash E? VB dash E is nothing but, okay, II. Yeah, now from this, find the value of VB dash E. Okay. Now from this, this is nothing but the VB dash E. VB, the voltage across these two terminals, B dash and E. Okay. The voltage across this terminal, B dash and E. Of course, yeah, this is VB dash E. The voltage across this B dash terminal and this center terminal, this is nothing but the VB dash E. So what is the value of VB dash E? The value of VB dash E is nothing but II by, so voltage, this is voltage is nothing but the current by conductance. Okay. So actually V is equal to IR, I into R. So here I consider the value of conductance. Okay, that's why R is equal to 1 by G. So that's why I by G. The value of voltage is equal to I by this G. So this GBDE, yeah, or GBDE, GBE, G B dash E and CE plus CC. J omega into CE plus CC. J omega into CE plus CC. Okay. So under short circuit condition, okay, we know the value of AA. A is nothing but the output current by input current. What is the output current? Output current is IL. Input current is the II. Okay. This II is the input current and this IL is the output current. So now we know the value of II is equal to IL by II. So that is nothing but the
So this is this one. Okay, now take from these two, simply we can obtain, substitute the, if we substitute this one here, then we will get IL by IA is equal to this one. IL by, am I clear? Simply substitute this VB dash E here. Okay, you will get IL is equal to minus GM into IA by GB dash E plus J omega into CE plus CC. So you bring this IA this side. IL by IA is equal to minus GM by GB dash E plus J omega into CE plus CE plus CC. CE plus CC. Okay. And we know the value of G, but we know the value of GB dash E. GB dash E is equal to 9 GM by HFE. Okay. So GM by HFE. We know the value of GB dash E. We calculated earlier. That I shown you. Yeah, GB dash E. So this is nothing but the GM by HFE. So while calculating the sorry. Yeah. While calculating the output conductance, we know the value of the GB dash E is nothing but the GM by HFE. So we know the value of GB dash E is equal to GM by HFE. GM by HFE. So also while calculating the capacitance, we know the value of the C, it is nothing but C, the both are, it is neglect, this is the larger one as compared with the CC. So we can neglect this CC. So this CE plus CC is approximately equal to the CE. So this is a very, very small. The CC is very, very small as compared with this one. So that's why you neglect this one. So this CE plus CC is approximately equal to the CE. Okay. Now we know the value of CE is equal to, of course, we have calculated the value of CE earlier, that is nothing but the GM by 2 pi ft. 2 pi ft. So that is nothing but the, now substitute the value of here, these values here. Okay, this is nothing but minus GM and minus GM by HFE plus J. Substitute the value of this, this. Okay, now we will get like this. Finally, we will get the value of A is equal to, if you take this 2 pi F4, this 2 pi, all these things, this is nothing but F4. This 2 pi can cancel, then J into, this you will take, this is nothing but, you will get like this. Okay. A is nothing but IL by IA, that is nothing but the G minus GM by this is. Now from this equation, we will get the value, we know the value of G, GB dash E, and this is neglected, then just this by this. Finally, we will get the value of AI is equal to this one. AI is equal to, by simplifying, by substituting the value of all these, this one GM, we know the value of GM, and are simply GB dash E. Some substitute the value of GB dash E here. Okay, so we have substituted the value of GB dash E here. That is nothing but the GM by HFE. J is nothing, omega is nothing but the 2 pi F. We have replaced the value of this omega is equal to 2 pi F. 2 pi F. And then CE, CC is all. So we can approximate the value of this. We neglected the value of CE, and we know the value of CE is equal to, we neglected the CC, we have no, this is equal to this one, and we have know the value of this one, I have substitute here. This is nothing but GM by 2 pi ft. This GM by 2 pi ft is nothing but CE. This J as is. This omega is nothing but 2 pi f. 2 pi f. Okay. Now after simplification, by taking the GM as a common, so here we have 1 by HFE, which is nothing but the JF by 2 pi get cancelled, JF by FT. So there is a GM in numerator and GM in denominator. The GM get cancelled. So one GM is cancelled. This is nothing but the minus 1. This is nothing. Am I clear? Please solve this one. Are you able to get the value of this AI, final value of AI? Can anybody solve? Hello? అమ్మా ఎత్తముకి
సార్ చేస్తున్నాం సార్.
చేస్తున్నారా? చేసి ఏ వచ్చిందా లేదో చెప్పండి నాకు.
Okay, sir.
Okay.
Sir, వచ్చింది సార్.
వచ్చిందమ్మా?
వచ్చింది సార్.
Okay, this is nothing but AI. AI is nothing but the current gain. So you will get like this. Now we'll simplify this one further. If you simplify this one, yeah, just a minute. If you simplify this one, this is 1 by HFE plus J into F by FT. Okay, if you're going to simplify this one, HFE is so HFE 1, this is 1, this will becomes 1 plus J into HFE into F by FT, this HFE becomes this. ఇది వచ్చిందమ్మా ఈక్వేషన్ నుంచి ఇది వస్తుంది చూడండి ఒకసారి. ఇది ఉందా? హెచ్ఎఫ్ఈని కామన్ తీసేసి పైకి పంపించేద్దాం. ఇది ఉంది కదా, ఇందులో లాస్ట్ ఈక్వేషన్ ఏఐ ఉంది కదా, ఇందులో 1 by హెచ్ఎఫ్ఈ బయటికి తీయండి. దిస్ విల్ బికమ్స్ 1, జే ఇంటూ హెచ్ఎఫ్ఈ ఉంటుంది, జే ఇంటూ హెచ్ఎఫ్ఈ ఉంటుంది. ఓకే, సో దిస్ విల్ బికమ్స్ 1 by హెచ్ఎఫ్ఈ ఇంటూ 1 plus j హెచ్ఎఫ్ఈ ఇంటూ ఎఫ్ బై ఎఫ్టీ. ఈ 1 by హెచ్ఎఫ్ఈ పై, ఇది 1 by ఇది కాబట్టి ఇక్కడ పైకి వెళ్తుంది. సో మైనస్ హెచ్ఎఫ్ఈ minus HFE by 1 plus J HFE into F by FT. J HFE into F by FT. Okay, F by FT. Okay na? వచ్చింది కదా. Now the value of A is equal to minus HFE by 1 plus J into HFE into F. HF by FT is nothing but FB. So I will explain later what is the F. Okay. Now if you from this equation we can rewrite AI is equal to this one. Now the value of HFE by FT. HFE by FT is nothing but 1 by FT. Okay, we can write this is HFE, this is 1 by FT. So we can write this one minus HFE by 1 plus FT. So this FT by HFT is equal to FB. Yeah. What is F beta, not FB, not F beta. F beta is equal to FT by HFE. So HFE by FT is equal to 1 by B, 1 by FT. So we can replace this one. Finally, we'll get the value of magnitude of this current gain. Magnitude of the current gain, it is nothing but the square root of real part and imaginary part. This J will be cancelled. Square root of square of this one and square of this one. Square of real part and square of imaginary part. Root over 1 plus F by FB whole square. Now where the value of FB is equal to this one. We can next class we will discuss about this what is FT, what is F alpha and what is F beta. So what is the relation between these two. So finally we will get the value of FT is equal to this one. Okay, at FT is equal to FB, it is nothing but 1. At FT is equal to FB, it is nothing but 1. So 1 plus 1, it is nothing but 2. So AI is equal to HFE by root 2. This is nothing but this is nothing but the 1 by root 1 0.1 by root 2 means 0.707. So HFE by 0.707. This is nothing but the 3 dB. We can now simply we know that the value of A is equal to the 1 by root 2 time of the lower frequency. That is nothing but lower frequency value of HFE. So thus the frequency up to FB is known as the bandwidth. Okay, the frequency up to FB is known as the bandwidth. So because of FB is equal to FB, it will become 0.707 times. This is nothing but the 3 dB. 3 dB frequency. Okay, so you can say that this is nothing but bandwidth. Okay, the frequency up to this FB is nothing but the bandwidth. So next class we will discuss about this. What is F or B, F beta, F, what is F beta, Ft and F alpha. F beta, F alpha and Ft. So we'll go through the expression for the F beta is nothing but the cutoff frequency. Okay, F beta is nothing but cutoff frequency. The beta cutoff frequency is also called as the FHFE, high cutoff frequency. Okay. So alpha cutoff frequency, what is alpha cutoff frequency? What is the T? Ft? Ft means unity gain frequency. Okay, Ft is the unity gain frequency. F alpha is nothing but the alpha cutoff frequency. F beta is nothing but beta cutoff frequency. Okay. Now from this alpha cutoff frequency, F beta cutoff frequency, we are going to express the value of the parameter of this Ft, F beta and F alpha. Ft is nothing but the unity gain frequency. F beta is nothing but the beta cutoff frequency. That is nothing but the root 2 times 1 by root 2 times of HFE. That is nothing but 0.70 times of 0.707 times of this HFE. Then alpha cutoff. What is the alpha cutoff frequency? Okay. I'll express. We'll explain these three in next class. Okay. Yeah. Okay. Now find the value of A. Finally, we'll achieve the value of A is equal to 1 by root HFE by root 2. HFE by root 2 is nothing but at F is equal to F beta. At F is equal to F beta, we'll get the value of A is equal to HFE by 1 by root 2. Or simply the value of A is nothing but the 0.707 times of this HFE. Okay. Now this is okay. The frequency up to F beta is known as bandwidth of the circuit. Bandwidth of the circuit. Okay. Yeah. Is it clear? Okay. Gain with resistive load. Next class we will discuss about this gain with resistive load. After that, parameters like F alpha, F beta. Ft is nothing but the unity gain frequency, beta cutoff frequency, alpha cutoff frequency. Beta cutoff frequency, alpha cutoff frequency. So after that, the gain bandwidth product. We'll discuss these three in next class. Okay, unity gain frequency, alpha cutoff and the beta cutoff. Alpha cutoff and the beta cutoff frequency. Okay, up to this, we have to find the collector emitter short circuit gain or simply C short circuit current gain we have find so far. Okay, we go through this validity of hybrid pi model and check the validity of the hybrid pi model can be validated by equating these hybrid pi parameters can be expressed in terms of H parameters. Okay. By drawing this equivalent circuit, we can express this hybrid pi parameters in terms of H parameters. This GM, RB dash E, RB dash E, RBB dash and RCE. So these are all hybrid pi parameters. So these are expressed in terms of HFE, HRE, HFP and HIE, all these things. So we can express this these are in terms of hybrid parameters. This is the validation of hybrid frequency parameters, validity of hybrid pi model. Okay. After that, we have gone through the CE short circuit current gate, calculation of the CE short circuit current gate. So by taking this equivalent pi equivalent circuit, we have assumed the output is shorted. RL is equal to 0. At RL is equal to 0, there is no So this C and RL is disappear because of this is very greater than this one. This is open circuited. We can redraw this circuit. When it is a short circuit, output is short circuited. There is no voltage. We can get any voltage. The voltage is equal to 0. The when the output voltage is 0, the voltage gain is also 0. So then we can express the gain in terms of current gain. So current gain is nothing but the output current by input current. Output current is IL and input current is II. So now from this we have calculated the value of IA and so this IL is associated with this VBE dash. Sorry, VB dash E. This VB dash E is an expression we can obtain under the short circuit condition. We get the value of this A. A is equal to this one. Finally, this is nothing. Okay. We have rewrite this equation and finally we achieve the value of AI in terms of beta cutoff frequency. The frequency at f is equal to f beta, that is nothing but the bandwidth. Why? Because if the value of f is equal to f beta, this will become 1 square is equal to 1 plus 1 is equal to 2 under root 2. This is nothing but the root 2, hfe by root 2. This hfe 1 by root is nothing but 0.707 times of hfe. So this is nothing but cutoff for 3 dB. So this is nothing but the beta cutoff frequency. Okay. So with this, I am going to stop. You practice this. This is one of the important derivation. Collector current, C short circuit current gain for hybrid pi model. So when you are asked to determine the C short circuit current gain for a hybrid pi model, take this hybrid pi equivalent circuit and assume the output is shorted. If the output is shorted, the value of take the value of RL is equal to 0, and the resistance in this output will be disappear. Okay, the resistances which are these resistance will be disappear, and this will become open circuited because of this is very greater than with this one, and then you redraw the circuit. In this circuit, there is an output voltage. The output voltage is 0. Then the output voltage gain also 0. Then so the gain that we consider here is the current gain. The current gain is nothing but the output current by input current. So take this equivalent circuit and then find the output current and finally achieve this expression for this AI. So this is one of the important derivation in this from this unit. Okay, determine the calculate the short circuit current gain, C short circuit current gain for the hybrid model. Okay, you practice once again. So you will get up to this AI is equal to 1 by root 2 times of HFE or 0.70 times of HFE, 0.70 times of HFE. Okay, so this is the formula for C short circuit current gain. Okay, so with this I am going to stop my presentation. So next class I will discuss about the alpha cutoff frequency, beta cutoff frequency, and unity gain frequency. Then resistive load, current gain with resistive load. Okay, current gain with resistive loads. Okay. Vasu? Hello? My A6. Ma?
సార్
వినపడుతుందమ్మా?
సార్ చెప్పండి.
హలో?
సార్ చెప్పండి సార్.
ఆపేద్దాం ఇక్కడతో.
ఓకే
అలాగే
సార్.
పంపిస్తాను. ఓకే రైట్. ఆ నెంబర్లు పంపించండి ఎంతమంది ఉన్నారు. ఓకేనా?
ఓకే సార్ పంపిస్తాను.
ఓకే థ్యాంక్ యూ. ఓకే థ్యాంక్ యూ ఆల్.